Yeah, hello everybody. Myself Rajeev, physics faculty. So, guys, today I am here to discuss gravitational potential due to solid sphere. Gravitational potential due to hollow sphere already discussed. Now we are going to discuss gravitational potential due to solid sphere. So, like previous cases, in the previous case we have discussed gravitational potential due to hollow sphere outside, at the surface and inside. Similarly, we are going to discuss here case first outside. So just see, first of all discuss outside, then at surface, then inside. Done buddy? Oh. So see, to calculate gravitational potential we have two methods. First, work done of external agent. We know that work done of external agent per unit mass is gravitational potential from infinity to this point, required point. Okay. Another point is that we know that delta V is equal to, minus I dot R dr. We know this relation, delta V is equal to minus I dot dr. If we will integrate to this one, so from here also you can calculate gravitational potential. Okay, and we know that to calculate the gravitational potential at any point, we should move from infinity. It means its initial position should be infinity and final position should be x. Here also initial position should be infinity and final position should be x. Now you can see here, suppose that this is the infinity, my dear. Here look, suppose this is the, okay, no, just see here, bit. Okay, suppose this is the infinity. Okay, just hold. Yeah. Suppose this is the infinity. So if you take this point, so at this point, this is the direction of field. Because gravitational field is what? Attractive in nature. So it will be towards the center. And this is the direction of displacement also. It means both are in same direction. So what is the angle between them? 0. Theta is 0. So cos 0 become 1. Cos 0 become what? 1. Okay. Now see, integration this one delta x. What is the integration of dx? X. So integration of dv will be v. So this become what? V. And its upper limit will be x, lower limit will be infinity, is equal to minus. Here a dot b. A dot b is equal to ab cos theta. So minus already a we can write gravitational field intensity Gm by x square, because we know that outside the solid sphere field intensity is Gm by x square into dx. Dr can be replaced by dx. Why? Because it is moving only along the x-axis. But here one mistake we are going to do. So for that correction we have to put here minus. Now you can ask why this minus. So see, because particle is moving from higher initial position to lower final position. See, if you look in this diagram, so suppose particle initially here, infinity, and right now final particle is here. So displacement is always final minus initial. So here you can see initial position is always greater than final position. So this result will be always negative. Okay, so this negative and this negative becomes plus. Now see, this negative become plus, and this is 0 because potential at infinity is 0. We know that this is our reference point. So Vx is equal to, this becomes Gm, and integration of this one minus 1 by x, and limit should be infinity to x. Now if you will put the value, then you will get the result. Potential at any point is equal to minus Gm by x. Minus Gm by x. So this is a result of gravitational potential outside the solid sphere. From here we can say field gravitational potential inversely proportional to distance. Again I am telling you, this minus represents that here field is attractive in nature. Minus potential means field is attractive in nature. Now see at the surface, second case. So see, second case, gravitational potential at the surface. At the surface means what? X should be our radius. So here it becomes minus gm by r. Now we are going to discuss one of the important case inside. If you will recall, so in the case of hollow sphere, inside potential is constant, but here potential will not constant. So we are going to find how we can calculate. So just see the process third, case third. Okay. Now see, suppose I have to calculate potential at this point P. It means x less than r. X less than r means what? Inside? Okay. So if I have to calculate potential at this point, so how we can calculate? See, potential means always work done by external agent to take a unit mass from infinity to this point. It means you have to move from infinity to this point. So first of all, you have to move infinity to surface, then surface to this point. Reason is, what is reason? Why I am telling you it cannot move? Why I am telling you you cannot move directly from here to there. You have to move first of all infinity to surface, then surface to x. Reason behind this one is, see, field intensity outside. Field intensity outside is what? Minus gm by x square, and field intensity inside, my dear, field intensity inside is what? Minus gm x by r cube. I hope you know this result. If you don't have idea of this result, then post your message, comment. I will make video on this one also, right buddy? So see, here field intensity outside and inside both are different, because I am telling you first move from infinity to surface, this become outside, then move surface to inside. Done buddy? Okay. So now going to apply the formula. So see, again same formula, dv is equal to minus I dot dx. But here initial position becomes infinity and final position is x. Here also infinity to x. Okay, this become what? V. Because integration of dv become v, infinity, and this become x. Okay, no issue. My dear, here I will broke this path. You have to move from infinity to where? X. But I will broke this path like that. Minus I dot dx from infinity to, tell me, r, minus I dot dx, and from r to x, because I told you infinity to surface, then surface to that required point. Okay. Now we know that this is this become directly dx, but this is a minus dx, because displacement is always here negative, because final position is always less than initial position, because initial position is infinity or final position is x. Getting my points? So simply I can write here, this become Vx minus V infinity is equal to, this is minus, okay, I outside, because we are talking about outside, so outside is what? Gm by x square, and dx is basically minus dx, right? Dx is what? Basically minus dx, and for this, its limit become infinity to r. Second is minus, again, inside field intensity is what? Gmx by r cube into minus dx, and here r to x. Done buddy? Now solve this one. So this becomes Vx and this becomes 0, because it is a reference point. Minus minus plus. So Gm outside, minus minus plus Gm outside, this becomes 1 by x square dx, infinity to r, okay, minus minus again plus Gm by r cube outside, because this is a constant, x dx, and limit become r to x. Done buddy? Okay, so now solve this equation fast. So this becomes Gm, this is minus 1 by x, limit become r and infinity, plus this becomes Gm by r cube. See, x square by 2 and this become r2x. I have already uploaded the video of integration, so you can learn how to integrate from that video, right? Okay, now put upper limit, lower limit one by one. Upper limit you will put here. So see, Vx is equal to, this become minus Gm by R, because infinity terms get cancelled out, 0. This become plus Gm by R cube. My dear, Gm by R cube. And I told you put upper limit. So upper limit x square by 2. Lower limit becomes minus R square by 2. Okay. If you will solve this result, so potential Vx is coming, my dear. See, this is minus Gm by R multiplied this one plus Gm x square by 2R cube plus and minus. So this become minus Gm, R square get cancelled, 2R minus Gm 2R. Add this two equation. So Vx is coming, my dear, minus 3Gm by R. Okay, plus Gm x square by 2R cube. Okay, now we know that this gravitational potential is inside. So can I write inside? At the place of x, I write inside potential. What we can take from here common? This will be 2. We can take from here common minus Gm by R. Minus Gm by R take common. So this become 3 by 2 minus x square by R cube. So this is a result of, my dear, this is a result of gravitational potential inside the solid sphere. Now you can take lot of special case like potential at the center. Just check at center. If we check at center, so x is equal to what? 0. So potential at center becomes minus 3Gm by 2R. This is the potential at the center. Potential at the surface, you know. So, getting my points? Potential at the surface, you know result. Okay. Now we are going to learn how to plot its graph. Potential versus x. See. So, if you will see here, so every potential, see, inside gravitational potential is what? Minus Gm by R, 3 by 2 plus x square by 2R cube. At the surface, minus Gm by R, and outside the surface, minus Gm by x, or simply you can say it is inversely proportional to x. Okay, then this minus represent what? Field is attractive in nature. Field is attractive in nature. So for a small time, for very very small time, like 5 seconds, 10 seconds, forget this sign. For 5 seconds, 10 seconds, forget this sign. Okay, just okay, some mistake going on. This is minus or plus. Okay, this should be plus, na? I think, yeah, correct, fine. So you can see here, if it is, no, here should be minus. Because it is coming minus, okay, sorry. Here, this is, okay. So for a small time, forget this all result. Now see, just consider on this part. My dear, consider on this part. If you will increase the x, so this value will decrease or increase? This value will decrease. Again I am telling you, all have negative sign. Reason? Because field is attractive in nature. Okay. So plot the graph. Just take a small practical view for more clear vision or feeling. Suppose that this is this value. So this is a constant. Only this will change. In that case, see, if you will increase the x, so this amount will increase. This amount will increase. Ultimately, what happen? This total value will decrease. Right? It means when x will be 0, so this value will be maximum. When x will be 0, this value will be maximum. Don't go on negative. Negative representing here. Negative will represent here attractive nature. So forget the negative. Then think, if x becomes 0, then this becomes maximum. It means potential will be maximum at the surface center. So here potential will be maximum. Now on increasing the potential, sorry, x, this will decrease, but this will decrease like parabolic. So this will decrease like that. Okay, like that. And it will decrease up to surface. X is equal to r. After that, it is inversely proportional to x. So it becomes like hyperbola. So this becomes like that. Okay. See, very easy. You can remember this equation very easily. Getting my points? Like that. Similarly, out, if you want to go another side, same graph will come like that. So this is a potential versus x of solid sphere. This is a potential versus x of solid sphere. If anybody have doubt, please tell me. Right? Okay. Thank you.